Hello everyone, this is our 6th MBP Python tutorial. In this session, we will explore a new feature in MBP 2026, Python plugins. First, we will provide an overview of what Python plugins are and the benefits of using them. Next, we will dive into the two types of Python plugins available. System plugins. These are predefined by MBP developers and cannot be modified. User plugins. These are custom Python plugins that you can create based on your specific needs. Next, let's dive into more details. What is the Python plugins? This is the feature that converts predefined Python functions into reusable plugins. This compatibility allows you to quickly access predefined logic, easily integrate custom logic into the MBP environment, and save time by reusing tested functions. By leveraging Python plugins, you can minimize repetitive coding and enhance flexibility with MBP, creating powerful tools that simplify building your modeling flow. Both types of Python plugins I mentioned previously can be accessed quickly through the Plugins button in the main menu. System plugins are predefined by MBP developers and cannot be modified. Currently, MBP supports one system plugin, and we plan to add more in the future updates. The existing system plugin is Model Parameter Compare, which includes 3 sub-plugins. Compare multiple models and display all parameters. Alternatively, display only the parameters that differ across models, or display only the parameters shared by all the models. This functionality allows you to quickly compare different models and gain a better understanding of how parameter variations influence device performance. User plugins are custom tools you create by writing code in the Python editor and exporting it as a plugin button, which appears in the main menu. This allows you to quickly access your custom functions and streamline your modeling flow. For example, you can design a plugin to arrange plots in the MBP main window according to your preference, making it easier to balance different device performance metrics. Next, I will show a quick demo of the system plugin and how to create user plugins. The system plugin can be accessed through the menu, Plugins, Model Compare. As I mentioned previously, there are 3 sub-plugins, which are used to show compared models in different ways. For example, here we have 2 VBIC models, and when we click for comparison, all the parameters of 2 models, no matter they are different or not, will show in this table. If you only want to check the parameters with different values, you can choose this difference only. And if you only want to check the parameters with the same values, you can choose these common parameters. For the user plugins, we need to open the Python script and create your plugin's code in the Python editor. Here, I will use a function that will rearrange your plots as your expectations as an example. After you have the code, click the Export Plugins button to export your code. Then, in this pop-up window, you need to give plugins name, such as Rearrange Plots, and the sub-plugin name. If your exported code is a task group, select the group run Python file in the path. If it is not a task group, select the Python file you want to execute directly. The export directory should be under MBSet user plugins. Then click Export Plugin. With click Refresh Plugins, you can see your plugin here and use it as needed. In this simple plot arrangement function, by specifying the plot names and conditions, you can easily display the plots in the desired layout in the MBP main window. In summary, MBP Python plugins provide quick access to custom functions created in the Python editor. These plugins can significantly accelerate the modeling process and enable seamlessly interaction with the MBP environment. Exporting and editing customized plugins is simple and efficient, making it easy to adapt your workflow as needed. Thank you for watching.